Alright, hello. Before everything happened, we were finishing up series and parallel circuits, and I wanted to put a number to your ability. So before we have a test, we have review, so consider this review. So the first thing you're going to want to do when you get your test, even before you open it, you're going to want to write down your formulas. So we had two triangles to help you remember. Old MacDonald had a farm. EI ohms is a measure of resistance. And we started back in Thanksgiving, so I for dessert. And we also put in units. Very angry orangutans want VH. So volts, amps, ohms, and watts for your units. And then for series and parallel circuits, okay, remember series circuit starts at the battery, comes out, and basically comes to ground or comes back around. Okay, no choices there. And a parallel circuit comes out, and then somewhere along the line the electrons can go this way or they can go that way. And then they can come back to their battery or go to ground. So right here you have a choice, so that's a parallel circuit. So we have voltage, current, resistance, and parallel for both series and parallel circuits. So we can look at all the components. Let's do power first. We're going to do power first because power is the same for both series and parallel. So power, you always add it up. P1 plus P2 plus however many you have. Same in a parallel circuit. Power 1 plus power 2 plus however many you have. Alright, series, remember it's a loop. There's only one place for everything to go, so current, I, is constant. Whatever flows out of the battery is going to flow through each resistor. Okay, and not going to be constant in a parallel circuit. It's going to have a choice. Some of the electrons are going to go here, some over here. So over here, the total current is, add them up. We know how much current flows through each of the branches. We know how much we have total. Parallel circuits have constant voltage. Remember that 120 voltage is what you want so your electronics don't burn up or wear out with low voltage. High voltage burns them out. And total voltage over here is going to add up. Which leaves resistance. Resistance in a series circuit, remember it starts out easy, we're just going to add them up. Alright, so lots of adding for a series circuit. Parallel, adding, and then total resistance is fractions inside fractions. So 1 divided by parentheses, 1 divided by R1, plus 1 divided by R2, plus ... 1 divided by Rn. So remember there's other formulas, but that one works in all cases. So that's one I teach you. So this is what you should know before you open your test. Alright, so when you open your test, or review, first question you want to ask yourself, and around answers to the nearest hundredth, what type of circuit is this? So for the first one, you should say parallel circuit. As it comes out and it branches here. So some electrons go here, some continue on. Another branch, some go down there, some continue on, and then it goes to ground. So you've got choices here, so it's a parallel circuit. So everything you know about parallel circuits applies, and they want you to fill everything else in. Alright, so I only give you one in each column, so you can't do anything in columns. Rows, I give you one in each row. So you really have to know what's constant in a parallel circuit. Voltage is constant. So bring the 12 volts all the way across. And from there we've got some choices. If you know E and I, you can find R with your triangle. So 12 divided by 1, 12 divided by 1 is 12. If you know E and R, can you find I? Same thing. E divided by R, so 12 divided by 2, 12 divided by 2 is 6. Alright, from there, what can we do from there? Oh yes, if you know P and E, another triangle, P divided by E, 3 divided by 12 will get us I. 3 divided by 12, so 1/4 or 0.25 amps. If we know E and I, we can also find R. So E divided by I will get us R. 12 divided by 0.25 is 48 ohms. Alright, from here, total current. We know the current has to add up, so 0.25 plus 6 plus 1, we get us 7.25 amps total. Total resistance, we're going to do formula. I know it has to be less than 2 ohms. We can do 1 divided by parentheses, 1 divided by 12 plus 1 divided by 2 plus 1 divided by 48. Pull up the calculator. Alright, 1 divided by parentheses, 1 divided by 12 plus 1 divided by 2 plus 1 divided by 48, close parentheses, equals 1 point, I'm going to the nearest hundred, so 1.655, so 2 zeros and 100, so we'll call that 1.66 ohms. We can check it because we can do E divided by I should give us 1.66. Bring the calculator back up. So E12 divided by 7.25, 1.655, so exactly the same. So that's good. Alright, finishing it off. Power. So if we're looking for power, remember we're going to do I times E. So I times E is 7.25 times 12. Some calculators were made for. Do I still have it or I closed it? On the calendar. Alright. 7.25 times 12. So 87 watts. I can go across the line. 1 times 12, and we need a calculator for that. 12. 6 times 12, 72. We can check it. 12 plus 72 plus 3 adds up to 87. So I'm pretty confident with this number. Alright. Alright, scrolling down. Number 2. What type of circuit is this? Alright, you start at the battery, come through resistor, 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 into ground. Alright, so that should say series to you. No choices. Alright, so I give you the same starting thing, but we're going to use different rules, so we'll get different numbers. Alright, so in a series circuit, what's constant? The current is constant. So 1 amp goes all the way across. Okay. From here, if I've got E and I, can I find R? Yes. You got your triangle. So 12 divided by 1 is 12. Alright, nothing to do there. If I've got I and R, can I find E? Yes, I can multiply. I times R is E. 1 times 2 is 2. And from there, let's go back to the first column. I times E will give us P. P-I-E. So 1 times 12 is 12 watts. I can do it over here too. 1 times 2 is 2 watts. Alright, and then that's the key here. I could do it a couple ways. So we could find P1 if I know this adds up to 12. 3 plus 2 is 5. 5 plus 7 will get me to 12. So that gives me a second one here. I could also use this one over here. I could do P divided by I to find E. So 3 divided by 1 is 3. 7 divided by 1 is 7. They should add up. 3 plus 2 is 5. Plus 7 adds up to 12. The power. E divided by I. 3 divided by 1 is 3 ohms. 2 ohms. 7 divided by 1 is 7 ohms. 3 plus 2 plus 7 is 12 ohms. Alright, so this is for a series circuit. So same numbers, 12, 1, 2, 3, but different rules get you different numbers. Let's pause there.